Hi, I'm Camille and this is Chem with Chem. So in this session, we're closing off addition versus condensation polymerization with polysaccharides. Now, if you missed polyamides and polyesters, be sure to check the links below in the description for those. If you're a first-time visitor to the channel, welcome. If you're a returning viewer, big up yourself. Remember to smash the like button, share, and subscribe. Let's get right into it. Our saccharide linkage is just a bond, oxygen, and a bond. That is what is linking the monomer units together. All right, so the monomer we're going to be using here is glucose. So we know that glucose is a simple sugar. If we have two glucose units joined together, we're going to get what we call a double sugar or what we call a disaccharide. And of course, if many of these units join, we get what we call a polysaccharides, hence the term polysaccharide. Now, I don't want to blow anybody's mind, but we know, or I believe by this time we should have come upon the formula, the molecular formula for glucose. And we know this from photosynthesis. Plants make food in the presence of sunlight using carbon dioxide and water, and we get glucose, C6H12O6. Now, we only need a representative structure for the glucose molecule, but for us to appreciate how the linkage or the saccharide linkage is formed, it's good to have an idea, just an idea of what the glucose molecule actually looks like. But we're going to only use a representative structure after we look at what it looks like. All right, so the glucose molecule with molecular formula C6H12O6, it actually looks like this. I haven't drawn this in a while. So where we have those lines joining, we have a carbon. So there's a carbon here, there's a carbon here, there's a carbon here, there's a carbon here. I'm gonna put it in. And then here we have another carbon, and then there's one here. CH2OH. All right, so we'll have hydrogen here, OH here, hydrogen here, OH there, and then OH there, and then hydrogen. All right, so this carbon is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So we can see why we have C6H12O6. We can count up the hydrogens to ensure that we have 12 of them. All right, so in case you can't find the 12th hydrogen, it's really here. All right, so that's one glucose molecule. Now, to actually show the linkage, and I'm gonna draw another glucose molecule structure just like this. So again, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So whenever we have glucose molecules joining to give us the saccharide linkage, this is where the joining takes place. It's between carbon 1 and carbon 4. So carbon 1 from one of them and carbon 4. So it's OH from either works with the H from the other one. And water will come out. The small molecule we'll get here is water. Now, of course, this will take a lot of time to draw. This is just a representative structure. I only show the link because when we actually represent the molecule glucose, which we can do using a simple, we can use X with OH at the front and an OH at the back, similar to what we have here. So that is fine. So this is representing a glucose molecule or a unit of glucose. So this can join with another one. You could put Y or A, anything you want in the middle for the variable hydrocarbon group. So this is fine though. This is fine. So this is another glucose molecule. So if both of these come together, it's the OH from the front one and the H from the one beside it. That will come off as water, and that will give us a disaccharide. So we would have OH from that side, X, then we'd have O, that's the linkage, and we'd have X, then we'd have OH. All right, so this would be a disaccharide. And to actually show the polymer, we would just pretty much convert what we have here into a repeating pattern. We could just do this on a new page. Or we could go back. So that is the disaccharide. So we could just represent, we could show the structure of a polysaccharide by just, let's see how we could convert this. We could take off the H here and we'd have O, and then we take off the OH from over here, and then we can just write that on a new page. So this would be the structure of starch. So we'd have bond X, O, then we'd have another X, O bond. All we would need to do is put a bracket around this and put N. And remember, so this is showing the structure of, in this case, could be starch, many glucose molecules joined together. This is a polysaccharide. So remember now that if you were to piece the end at one end to the other end, we should end up back with the linkage that represents the polymer in question. In this case, it is a saccharide linkage. So we're going to circle it, and that's the saccharide linkage being represented right there. Okay, so this is our starch molecule, which is also, or which is a polysaccharide. So we have many saccharide linkages within the structure, so we call it a polysaccharide. So with this, we've come to the end of this video on condensation polymerization. If you have not looked at the one for addition polymerization, then be sure to check it out in the description below, or you can just check the card above for that one. Remember to like and share the video, and consider subscribing. Hit the bell also so you never miss out when new content is shared. Thank you for joining Chem with Chem. Couple later.